Start the video, we will start again with a story which will relate to the idea of chemiosmotic hypothesis. So the story is about a dam. So dams are made to make a water reservoir, and in that reservoir water is stored to be later on used to produce hydroelectricity. And we all know that hydroelectricity is produced by storing a water in a reservoir, then releasing the water, and then using the flow of the water to generate electricity. So you will be amused to know that the same kind of mechanism is used to produce ATP in our system. The ATP synthase enzymes which synthesize ATP use certain chemical gradients, and the flow of those chemicals result in the formation of ATP from ADP by means of phosphorylation. So let's see how that happens, and the process by which that phosphorylation of ADP into ATP takes place is explained by the chemiosmotic hypothesis. In the biological level, certain protons are or other chemicals like sodium ions or any other ions are stored, which are represented over here by the red balls, are stored in a membrane bound reservoir, and from that reservoir these are released through a channel of those ions, and this flow of these ions through that channel results in the formation of ATP from the ADP. Now let's see how this happens in details. So this procedure, or the chemiosmotic hypothesis, or the process of chemiosmosis, requires an enzyme which is known as ATP synthase. Now in our syllabus we have the FOF1 ATP synthase. So what is this FOF1 ATP synthase? This FOF1 ATP synthase is a specific type of ATP synthase enzyme which utilizes a proton gradient to produce ATP from ADP. Now this ATP synthase enzyme has two subunits. One is the F1 and another one is the FO. The FO is a transmembrane proton channel which facilitates the flow of protons from the reservoir out of that reservoir, and F1 is the part which catalyzes the process of ATP synthesis by combination or by ligation of ADP with inorganic phosphate. Now one thing that you should be keeping in mind, that this ATP synthase is not synthetase, it's synthase. Most of the time students or even some teachers make this mistake while teaching or while reading, that they say it's an ATP synthetase. It's not an ATP synthetase, because synthetase are those enzymes which bring about synthesis upon expense of ATP. But ATP synthesizing enzyme does not utilize ATP while synthesizing ATP. Just think about it. If somebody is utilizing ATP to synthesize ATP, then that becomes very much ridiculous. So over here what happens, the enzyme is synthase. Synthase are those kind of synthetic enzymes, those who carry out synthetic processes without utilizing ATP, or passive synthesis process. Whereas synthetases are enzymes which require ATP for the synthetic process. So hence over here the ATP synthase is a valid term. ATP synthetase is not the term. Keep it in mind, because in examination, to confuse you, both the terms can be given in the option. Like the first option will be ATP synthase, another option may be ATP synthetase. So the answer is synthase. Another mistake that teachers or students make, that they say there is FOF1 ATPase. ATPase is a different kind of enzyme and ATP synthase is a different kind of enzyme. ATPase is an enzyme which induces or which catalyzes the process of ATP breakdown into ADP and inorganic phosphate. And the ATP synthase has the exactly opposite role. It has the role of synthesizing ATP from ADP and inorganic phosphate. So ATPase is a catabolic enzyme, whereas this ATP synthase is an anabolic enzyme, or it has a synthetic role that has a breaking down or lytic role. So these 2 points, it's not a synthetase and it's not a ATPase, should be kept in mind. So this was in brief about the enzyme that we require for the process of chemiosmosis. Now we require a proton gradient or an ion gradient. For our syllabus, we need a proton gradient because we have FOF1 ATP synthase. Now to make the proton gradient we need a barrier, and in case of biological systems barriers are in most of the cases unit membranes. So over here also we create a proton gradient. Now this proton gradient is both electrical as well as chemical because they have a charge separation. That means where the concentration of proton is high, over there the positive charge is high, than the region where the proton gradient is low, because over there the charge is also low. So over here we have a electrical gradient. At the same time, where we have more protons has a more high proton concentration, or hence a higher acidic concentration with respect to the region where we have less protons, and hence less protonic concentration or less acidic concentration. And thus the electrical gradient and chemical gradient can be combined together and can be called the electrochemical gradient. So proton gradient is an electrochemical gradient, and this electrochemical gradient of proton is said to contain a electrochemical potential or electrochemical potential energy, which is captured by the phosphorylation of ADP to form ATP, and this gives us the energy, it is said. So now once we have learned about the enzyme, we have learned about the proton gradient, let's move further. Now we come to the place where this reservoir is made. Now we have to take a reservoir in which we will be reserving the protons to produce a proton gradient. So in case of chloroplast, it is done inside the thylakoid of the chloroplast, inside the thylakoid lumen, the protons are stored to create and this is the reservoir, and this creates the electrochemical gradient. In case of mitochondria, the same reservoir is the intermembrane space of mitochondria, the space between the inner membrane and the outer membrane of mitochondria. So this is the space which is a reservoir. In case of the thylakoid of the plants or in the chloroplast, the thylakoid membrane has that enzyme FOF1 ATP synthase. In case of mitochondria, the inner membrane has the FOF1 ATP synthase, and the F1 part of that FOF1 ATP synthase is directed towards the matrix of the mitochondria. Now the third thing that we require is a proton pump. The proton pumps are those transporter proteins which will be transporting the proton against their concentration gradient to create the electrochemical gradient across the membrane. So proton pumps are active transporter proteins. If you don't know about the transporter proteins, go to my channel and check out the video on transport in plants. That will help you to understand about the different transporters. Now the proton pumps, what they do, pump, as I mentioned in that video, is a word used for the process of active transport. That means transport against the concentration gradient or against the electrical gradient or anything against the gradient is the work of pumping. So from the name itself, it is clear that these transporter proteins are pumping or transporting certain chemicals, in this case the proton, against their concentration gradient. Now this transporter proteins aid in the formation of that electrochemical gradient. Now how they get the energy to pump? Most of the transporters get the energy by lysis of ATP into ADP and inorganic phosphate. But these proteins are a bit different. These proteins have certain other mechanism by which they gain the energy. These proteins acquire electron from NADH2 and FADH2. So this NADH is not NADH2, it's NADH, I misspoke. So NADH and FADH2, these are universal electron acceptors. These substances accept electron from the catabolic reactions. Most of the catabolic reactions in our body are oxidative in nature. That means by after each step, those processes release electrons. Those electrons are taken up by these NAD plus and FAD to form NADH and FADH2, and these universal electron acceptors, donors, accept electrons over there, and now these electrons are given to these proton pumps, and that electron is transported through an electron transport chain, and while the electron passes from the electron transport chain constituted by those proton pump proteins, reaches a final electron acceptor, and in this pathway this electron releases some energy from it, and this energy is utilized by these proton pumps to pump the proton. across the membrane against the gradient. So the energy of pumping of protons is achieved from those electrons. Electrons are achieved from the catabolic pathways, and this pumping of protons produces a proton gradient, electrochemical gradient of proton. This electrochemical gradient of proton is utilized by FOF1 synthase to produce the ATP from ADP and PI. So this is in short the idea of chemiosmosis. So why it is a chemiosmosis? Chemical is osmotically the chemical is showing a property of osmosis. Over here the chemical is a proton, the proton is showing a property of osmosis, and by that energy is being produced. So this is an idea of chemiosmosis, and this is an hypothesis which is chemiosmotic hypothesis proposed by Peter Mitchell. So you have to keep this in mind, the name of the scientist. So this was in short the idea of chemiosmotic hypothesis. Please, if you like this video, please hit the like button, share this video among your friends, and like my Facebook handle, Instagram handle, and my Quora. Thank you to you. My YouTube channel is youtube.com/ayanparecha. Thank you.